Okay, ladies, first I'd like you to pause this and complete this long division problem. All right, so let's double check your work now that you've paused and completed it. Remember, for long division, you begin with division. 2 divided by 2 is 1. Then you multiply. 1 times 2 is 2. And then subtract and bring down. Then you'll divide again. 9 divided by 2 is 4. 4 times 2 is 8. Then subtract. 9 minus 8 is 1. Then bring down. 17 divided by 2 is 8. 8 times 2 is 16. Then subtract and again bring down. 15 divided by 2 is 7. 7 times 2 is 14. And 15 minus 14 is 1. So our result is 1,487, and you can list this remainder as 1/2 or 0.5. The reason I ask you to go through a simple long division problem is so you would review the steps to long division. Those are divide, multiply, subtract, bring down, and then fifthly, you repeat the process. Let's look at that long division with example 8x cubed minus 1 divided by 2x minus 1. With long division of polynomials, we'll put 2x minus 1 divided into, and notice our highest degree is 3. So if we begin with 8x cubed, I must have a place marker for x squared, x to the first, x to the 0. There is no x squared term, so my place marker is 0x squared. There is no x to the first term, so my place marker is plus 0x. And then there is an x to the 0 power, which is the constant minus 1. Remember the first step in long division, to divide. We always divide the first term inside by the first term on the outside. I'm going to do some scratch work over here to the right. So essentially I am dividing 8x cubed by 2x. We know 2 will go into 8 4 times. X to the third divided by x is x squared. So our first term is 4x squared. You should always keep the like terms lined up vertically. So 4x squared. Remember, the second step of long division is to multiply. 4x squared times 2x is 8x cubed. 4x squared times -1 is minus 4x squared. Remember, the third step with long division is to subtract. Remember, when you subtract, you have to distribute to both terms. So this becomes plus -8 and plus +4. The 8x cubes will cancel, and we have 4x squared, bring down 0x. Again, we will divide our first term on the inside by the first term on the outside. So if I come over and do some scratch work, that's 4x squared divided by 2x. 4 divided by 2 is 2. X squared divided by x is x. Keeping my like terms lined up vertically. Now multiply. 2x times 2x is 4x squared. 2x times -1 is minus 2x. We'll continue our steps of long division by subtracting. We subtract the entire binomial, so this becomes plus a negative and plus a positive. The 4x squareds cancel, and we have 2x, and now bring down the -1. We still have more division to do. The first term inside divided by the first term outside. 2x divided by 2x is 1, so this is plus 1. And we must multiply now using the distributive property. 1 times 2x is 2x. Positive 1 times negative 1 is negative 1. We must remember to subtract. When we distribute, that becomes plus a negative and plus a positive. And both cancel, so we have a remainder of 0. So when we divide 8x cubed minus 1 by 2x minus 1, this is the polynomial that is our solution. In the event that you do have a remainder, please do not write r for your remainder. Please write your remainder as a fraction. For example, if the remainder for this problem had been 2, then I would expect you to have written your remainder as 2 divided by 2x minus 1. If you look at goal 2, use synthetic division to divide polynomials by binomials of the form x minus k. Remember, for this form, the coefficient of x must be 1. So this must be 1x minus k, where k is a constant. So let's use synthetic division to divide, and we'll be dividing by x minus 5. Double check, is this the form x minus k? It is. And remember that k is equal to 5. So with our synthetic division, we'll place the value of k here and then list the coefficients of each term, remembering to check that if our highest degree is 3, we have a place marker for all descending powers. So 3, negative 17, positive 15, and negative 25. And just to confirm, x cubed, x squared, x to the first, x to the 0. With synthetic division, we begin by bringing down the first coefficient, and then we multiply. 3 times 5 is 15, and then we add the two terms. Negative 17 plus 15 is negative 2. And then we multiply. Negative 2 times 5 is negative 10. And we add. 15 plus negative 10 is 5. We multiply. 5 times 5 is 25. And then we add and get 0. 0 is our remainder. 5 is our x to the 0 term. Negative 2 is our x to the first. And 3 is our x squared. So our polynomial after division by x minus 5 is 3x squared minus 2x plus 5. Would you please pause the video and complete number 2? Once you've practiced number 2, come back and check your answer. Now that you've completed and checked, or completed number 2, let me go through it with you so you can check. X minus k is the form. That's x minus a negative 3. So k is equal to negative 3. The highest power is 4, so we need to make sure we have a place marker for all descending powers from 4. The coefficients are 1. There's no x cubed, so place marker 0, negative 10, negative 2, and 4. Let's confirm x to the 4th, x to the 3rd, x to the 2nd, x to the 1st, and x to the 0. Remember, with synthetic division, we bring down, multiply 1 times negative 3, then we add, multiply negative 3 times negative 3, we add, we multiply negative 1 times negative 3, we add, multiply 2 times negative 3 is negative 6, and we add, and we now have negative 2. If we write this in polynomial form, negative 2 is our remainder, x to the 0, x to the first, x to the second, x to the third. So our polynomial after division by x plus 3 is x cubed minus 3x squared minus x plus 2 plus, not plus, x to the third minus 3x squared minus x plus 2 minus 2 divided by our divisor x plus 3. Now, I would like for you to look at this, explore the concept. It asks us us to evaluate f of 5. In the previous example, we did synthetic division by 5 and came up with 3x squared minus 2x plus 5. So if we evaluate f of 5, we'll plug 5 into our original polynomial. That gives us 3 times 5 cubed minus 17 times 5 plus 15 times 5 minus 25. If you evaluate this, you should come up with f of 5 equals 0. Notice that f of 5 equals 0 matches our remainder in this previous example of 0. So when we evaluate the value of k, this value should match the remainder of when we divide it. Let's evaluate f of negative 3. For f of negative 3, that's negative 3 to the 4 minus 10 times negative 3 squared minus 2 times negative 3 plus 4. When you evaluate f of negative 3, that's equal to 1. And I think I've made a mistake somewhere. Hold on just a moment. 1, 0, negative 10, negative 2, and 4. Okay. So bring down 1. That's negative 3, 9. Okay, the mistake is right here. Yes, negative 1 times negative 3 is positive 3. My apologies, I added those instead of multiplied them. Negative 2 plus 3 is 1. 1 times negative 3 is negative 3. And so I have a remainder of positive 1. Which makes this, since this is positive 1, this is plus 1 over x plus 3. My apologies there. So what I'd like for you to notice is that when we evaluate f of negative 3, it is equivalent to the remainder when we perform synthetic division by 3. So I'd like you to write a statement that explains the concept and the relationship between the remainder in synthetic division and the value of the function when we evaluate at k, and bring that with you to class tomorrow. Don't forget to do the homework problems in section 2.3. You're only required to do 13 up to problem 29 on your syllabus. Thank you.